Today in class we worked on special right triangles, and we worked on the 45, 45, 90. So first we're going to simplify radical expressions, then we're actually going to solve equations with radicals in them, and then we're going to use that information to help us find the missing side of a 45, 45, 90 triangle. So we started out with these fractions. We have 1 over root 3, and we talked about what it takes to simplify it. To simplify it, you can't have a radical in the denominator. So to simplify this, we kind of manipulate the idea that we're going to multiply this fraction by 1. Because if we multiply it by 1, we're not changing it in the way we manipulate it. Instead of multiplying by 1, we say let's multiply top and bottom by the radical. So root 3. So we take the top, 1 times root 3 is just root 3. On the bottom you get root 3 times root 3 is the square root of 9. The square root of 9 is 3. And we learn that if we multiply a radical by itself, then we just get that number that's inside the radical. So on B, we want to get rid of that root 5 in our fraction. So we multiply by root 5, top and bottom. It's the same as multiplying by 1. And then we get 2 root 5 on the top, and then we have a 3 already, and then this root 5 times root 5 is the square root of 25, which is just 5, and then we're going to multiply the bottom because they're both outside of the radical. 3 times 5 is 15. The last thing that you would look is, can we simplify those two numbers? And no, we can't, so we just leave our fraction as it is. On C, we talked about if they have the same index, and the index is this number here. It's a 2 because it's a square root. If it's anything other than a 2, it'll have that number written. If those are exactly the same, then we can divide these numbers if they divide nicely, and 5 does divide nicely into 10, so this just becomes the square root of 2. 5 goes into 10 twice. Okay, we're going to use that idea here when we solve each equation. To solve each equation, you want to isolate x. So to get x all by itself, the first thing we're going to do is get rid of that root 3 by dividing it. And we have 12 root 3 over here, and then we talk about, well, we can't have that radical in the bottom, and that's, or in the denominator, and that's what we just worked on. So we're going to multiply by root 3 over root 3. And that gives us 12 root 3. And root 3 over root 3 times root 3 in the denominator gives us just 3. And then this 3 can divide into the 12 4 times. So 4 root 3 is our simplified answer. On B, to isolate the x, we go ahead and divide by root 2. And we can divide those, and we talked about if they have the same index and these two numbers are divisible, then we can just go ahead and divide them. So 20 divided by 2 is 10. We leave the radical, and you get the square root of 10 equals x. On C, we got to isolate the x by getting rid of the 5, so we divide by 5. They divide there. On the left side, 5 does divide into 15 3 times, so 3 root 3 is your simplified form. Okay, so we did example 1 and 2 to prepare us for this next part. Right triangle is a triangle that has one right angle, and we've actually talked about this before. An isosceles right triangle is when one of the angles is right and the other two angles are congruent. They're exactly the same, and they're each 45 degrees. So I have one drawn here, and I'm going to say, what if this x equals 1? Well, because it's isosceles, we know that these two sides are exactly the same, so that's a 1 as well. I'll erase this for just a second. And we don't know C. So we do have a right triangle, so we can use our Pythagorean theorem. Remember, that's 1 squared plus 1 squared equals c squared. A squared plus b squared equals c squared. And then 1 squared is 1. 1 plus 1 is 2. And then to solve for C, we take a square root. We do the opposite of squaring, which is to take the square root. So we have root 2. So C here is equal to root 2. I'm going to do something a little sneaky. I'm going to put a 1 right there. And I'm going to say, if you notice, in a 45-45 or an isosceles right triangle, the legs are exactly the same. the hypotenuse is root 2 times bigger than the leg. So then we said, what if this was 5? Then it would make this other side 5, and it would make the hypotenuse 5 root 2. And then I said, what if this side was 15? Then the side over here would be 15, and the hypotenuse would be 15 root 2. And so we said we can start generalizing some ideas with an isosceles right triangle. So before we get there, to solve a right triangle, you got to find all the angles, all the sides. So if you remember, a triangle has 3 angles and 3 sides. If we know we have the 45, 45, 90 degree triangle, then we have all 3 angles. So what we have to do is find the sides. To find the sides, I'm going to give you 2 formulas. The first one, leg equals leg. It's really easy to remember. The second one, a hypotenuse is root 2 times bigger than the leg. So I'm going to say the hypotenuse is the leg root 2. With those, we're going to use them to solve these triangles. But before we can use them, we have to verify that we have a 45, 45, 90 degree triangle. So here's our 45. We know that the smaller or the acute angles of a right triangle are complementary, so they have to add to be 90. And we instantly know that those are both 45. So we know our other leg has to be 12, because 12 was given to us. And the hypotenuse is equal to the leg times root 2. So this is 12 root 2. Now you could always do your a squared plus b squared equals c squared to find this, but this is much faster. Okay, so on B, again, you want to verify that you have an isosceles right. These tell you that it's isosceles, so then we automatically know these angles are 45. And we identify this 15 as being the hypotenuse. So I'm going to use that formula that says that the hypotenuse, 15, is equal to a leg times root 2. From here, to solve for L, we just divide by root 2, which is why we practiced examples 1 and 2. And then you have to get rid of that root 2 by multiplying top and bottom by root 2. So we get 15 root 2 all over. Root 2 times root 2 gives you 2. And that's your leg. And of course both legs are equal, so you have both legs. On C, we know one angle is 45, so we automatically know the other angle is 45. The root 20 is our hypotenuse, so we'll use our formula. The hypotenuse, root 20, is equal to our leg, root 2. And to solve this, we divide by root 2. And these divide out over here. And we talked about if they have the same index, then we can go ahead and divide the numbers in the radicals. So 2 divides into 20 10 times. So we get the square root of 10 is equal to our leg. And both our legs are the same, so I'm just going to write it once. On D, we do know we have a 45, 45, 90. And the side that has been given to us is a leg. So we know our other leg is 16 root 2. And we know that the hypotenuse is the leg, in this case 16 root 2 times root 2. So from here, we're going to take root 2 times root 2 is 2, or the square root of 4, which is 2. And 16 times 2 is, oops, 32. All right, that should help you with your 9-3 special right triangles. Good luck.